Welcome back. We've got another one. Why don't cats tell stories? They only have one tail. Okay, we are talking about multiple transformations today. So we're going to combo them, put them together. Okay, now what I've got here is just a little bit of this is your general notation. It doesn't change too much from here, but it can come up as different things. But usually, if I'm talking about a shift left and right, it's given by the letter H. If I'm talking about a vertical shift, it's usually with a K or sometimes a plus C. Your horizontal dilation, it's normally with a scale factor of A, and then your vertical dilation is a scale factor of B. So these two here, these bottom two, you would have completed in the last video. But these ones here, they should ring a bell because it kind of hints at our formula here, which I hope you recognize is, yes, a circle. Okay, now that's your quick little recap. Now, what happens with multiple transformations is the way that you transform it is not important. So it means that they commute. Now, that's just a fancy word to say that I can move to the left and then move down, or I can move down and move to the left, and it will be the same thing. Okay, so order is not important. There's one case where it is important, and it's unless the translation and the dilation are in the same direction. So, for example, I might move something down a little bit, and then I'll vertically dilate it. If it's two things in the same direction, so here vertical translation and vertical dilation won't work. Okay, anything else where I can do any other combination as long as I'm not dilating and translating in the same direction, you should be fine. Now, again, just let me touch on this. If I say translation, it just simply means move. Okay, I'm not doing anything. I'm not making it larger or smaller. I'm simply just translation just means to move left, right, up, down. Whereas a dilation means that's when we start to stretch things out, make it skinnier, make it fatter, that kind of idea. Okay, so I'm going to jump straight to the questions. We'll say fx equals to x squared plus 4, and it's translated left 2 units and vertically dilated by a factor of 3. To find the equation and graph it, I can do either one of these. So I can move it left first because that's horizontal, and then we're dilating vertically. So as long as they're not in the same direction, we can go either way now. Let's do this two ways. The first one would be to do it via, what do you call it? Graphically. But then we're going to do it mathematically so we can be a bit more precise. Okay, so x squared plus 4 is a nice parabola that cuts at 4. Okay, now what happens is after we do that, let's translate it 2 units to the left first. So that means now it becomes 2 units to the left. It now becomes this guy. And then now let's do our vertically dilate it. So we know that right now it still kind of touches at 4. But if I vertically dilate it, what's going to end up happening now is it's going to become a lot skinnier. Now, I actually don't know what that's going to look like. So I'm going to do the math and I'm going to double check this. Okay, so this is probably the more helpful part. If I have this f of x equals to x squared plus 4, we know that x minus h will move it to the right. So in this case here, I'm actually moving it 2 units to the left. So it's going to be x plus 2 squared. Okay, in case you are wondering where I got that from, let me break it down. It's because it's x minus, and in this case, h, normally h is to the right, so I've made it negative 2. Okay, so that's where that comes from. And I still have that plus 4. And so here, you can see that in this particular case, my value here, let's see, x plus 2 squared, yeah, minus 2 plus 4. It's just going to be there, actually. And now if we do, let's do the vertical dilation. This is probably the more difficult part. If I'm doing a vertical dilation, that means I replace x with sorry, y with y on 3. So that means this is going to be y on 3 should equal to x plus 2 squared plus 4. Yeah, and this is where I am correct. This would just be 3x plus 2 squared. And don't forget, because I'm multiplying everything through by 3, that 4 now becomes 12. So instead of 4, this now becomes, and I'm not going to fit it on here, but let's say, for example, that's the final transformation. It'll be somewhere up here. It'll be a little bit skinnier. And then I'll say that that's at 12. Okay, again, not to scale, but we can see that after these two transformations, move to the left, and I've dilated it, which in this particular case means it's the whole thing's moved up. That there becomes your new graph. Okay. Now we're going to have a different type of graph, and we're going to do a couple different things with this one. We're starting with an x minus 3 squared plus y plus 1 squared equals 9 circle. We're going to translate it down 2 units, and we're going to translate it horizontally dilate it by a factor of -1. So we can see here that down 2 units, that's vertically, but this one's horizontally dilated. So that means we can do these in any order that we please. Okay, I tend to go in the order that is actually there. So again, let's see what we can do here. First of all, this is a circle. We can recognize it with the 2 squares. Now we also know that our center, which is HK, is in this particular case going to be 3 minus 1. Okay, that's going to be the center of our circle. So if you need to recap that, watch my circles video or further graphs from year 11. That'll explain that. Now, your center is 3 minus 1. So let's try to keep it roughly to scale. 3 minus 1. And we can see here that we're going to have a radius of 3. So something like, yeah, okay, something like that. That's going to be our circle. Now, because of the magic of the iPad, let's translate it first. What we can see here is it's translated down 2 units. So that means I can move this down 2, that's down 1, that's down 2. So now my new center is now this guy, I'll do in the blue. Still a radius of 3. And then I'm horizontally dilating by a factor of -1. Now, the negatives tend to throw people off. That's why I recommend go and do it mathematically. So first things, down 2 units, x minus 3 squared plus y plus 1. If I'm moving it down, that's a great question. What did we say? If we're shifting up vertically, it's y minus k. So in this case, it's going to be y plus k. So let's put it in here. So essentially, mathematically, I'll replace this y with y plus 2. Because -2 would be up 2 units. So we're going down. Down is plus. I know that's going to be a bit weird. And it was y plus 1. So my bad, guys. What this would be is instead of y plus 1, I now add another 2. So it'll be y plus 2 plus 1. Okay, squared equals to 9. So far that's what we've got. So essentially it'll be x minus 3 squared plus y plus 3 squared. Okay, now you can see that that lines up so far in terms of our dilation, because we are now at -3. Okay, and that's 3. So far that makes sense, but now here's the horizontally dilating. Every time we horizontally dilate, let's do this in red. That means if it's horizontal, I'm replacing x, and I'm replacing that with x on, in this case, -1, or in other words, -x. So this is where our life gets a little bit gross. It's going to be -x minus 3 all squared plus y plus 3 squared equals to 9. Now, if I'm horizontally dilating something, mathematically, what you see there is what you get. But I believe if you're horizontally dilating, it's just going to actually reflect. Okay, so what should happen now, I'm hoping, it should move onto the other side. And it should become this guy here. If I drew that right. Should be it. Okay, so if the reason that I say that is, remember before in the last video, if I did a -1 vertical dilation, it just kind of flipped across the axes. So very, very similar here. In this particular case, because we're now doing a horizontal dilation of a factor of -1, it's going to flip from the right to the left-hand side. So again, I probably should have drawn this circle slightly larger. Still not the same size, but maybe a bit closer. Okay. So now that would be the new circle and graph. Okay, I would keep that as is. I would not expand, but that is what it is. All right, hope that helps, and I'll catch you guys in the next one. Bye.